Hello guys, in this particular video I am going to explain you how you can solve this particular question number 48 of chapter 5 from this book Engineering Circuit Analysis by Hayt, Kemmerly, Durbin. So this question number 48, it says that for the circuit 5.89 means this question. So for this circuit you need to determine the Norton equivalent connected to resistor R out. So we need to determine the Norton equivalent across this AB terminal. So to determine the Norton equivalent circuit, the main thing is that we need to determine the equivalent resistance. Means first of all we need to remove this R out. So if I remove this R out, I will get the circuit something like and over here, like over here it is given 4 ampere, but it should be 4 milliampere because if it is 4 ampere, then this current will be too large in comparison to this currents, because over here the resistance is in kilo ohm, so and voltage it is in 2 volt. So if approximately if we determine the current because of this 2 volt, so it will be V upon R, right? So it means 2 upon 2k. 2k means 2000, so it is 0.001 ampere, means 1 milliampere. So you can see that because of this voltage 2 volt and 3 volt, the current is in milliampere. So if this current source is in ampere, then it is going to be very large in comparison to this, and the role of this particular voltage source is it is ignorable. So there must be some typo mistake in the question, that it instead of 4 ampere it should be 4 milliampere. So it is the reason I take it as 4 milliampere. Right now, once we get this circuit, once we remove R out, right now in this circuit we need to first determine the value of RL, the Thevenin or the Norton resistance. And to calculate the Thevenin resistance, simply what we need to do, we need to deactivate the independent sources. So if we deactivate this current source, so what we are going to do, we are going to replace it with open circuit. Then this will remain as it is, 1k. Then coming to this voltage source will be short circuited. Then this resistance remain as it is, 2k, and then this will be short circuited. So we get this. And now across AB we need to determine the R equivalent, which will be we have only 2 resistors in parallel, so it will be 2 by 3 kilo ohm. 2 by 3 kilo ohm. And this R equivalent will be our Rn, or Thevenin resistance or Norton resistance. So Rn will be R equivalent, which is 2 by 3 kilo ohm. Now once we get the Rn, after that we need to determine the Norton current. So to determine the Norton current, what we need to do, we need to short circuit this AB terminal, and this current we need to determine, the current flowing between AB terminal after short circuiting. So to determine this, what we can do, simply we are going to apply the mesh analysis, or we can apply any other theorem also if you want. So if we write if we consider 3 loops, I1, I2, I3, and now if I write the mesh equations, so for the first loop, like I1 is this, so I1 will be directly minus 4 milliampere. For the second loop, writing equation for this, I will get I2 minus I1. For this it will be plus 2, and for this it will be 2 I2 minus I3, right? And for the third loop, it will be like starting from this 2k, it will be like plus in the tail, minus at the head, so it will be plus 2 minus, so 2 I2 minus I3, I3 minus I2, then coming to this minus 2 plus, so minus 2, then coming to this 3 volt plus 2 minus, changes from plus to minus, so it will be minus plus 3 equal to 0. So from these three equations, like if I rearrange this first equation, so I will get like minus I1, then I2 and 2I2, so it will be plus 3I2, and then we have this minus I3, so minus 2I3, and this is plus 2, taking it on the right side I will get minus 2, right? And similarly, now substituting the value of this I1 as minus 4 over here, I will get minus 4 plus 3I2 minus 2I3 equals to minus 2. So taking this minus 4 on the right side over here, I will get 3I2 minus 2I3 equals to minus 6. So this is our first equation. Now similarly for the third equation that we obtained from the third loop, so we will get like first minus 2I2, so minus 2I2, and then plus 2I3, and then we have this minus 2 plus 3, it is plus 1, taking it on the right side we get minus 1. So this is our second equation. Now solving these two equations, we will cancel this out and we get I2 is equals to minus 7. I3, now substituting the value of I2 in this equation, I will get minus 2 minus 7 plus 2I3 equals to minus 1. So 2I3 is equals to, this is 14, so taking it over here it will get minus 1 minus 14, so 2I3 is equals to minus 15, I3 it is equals to minus 7.5 milliamperes. So I3 is minus 7.5 milliamperes, right? And I1 already we know that I1 is minus 4 milliampere. So once we get these three, I1, I2, I3, now again coming back to this circuit diagram, we can see that we need to identify ISC, right? And this ISC, it is equal to I3 current, because the direction of I3 and ISC are same, right? So our ISC, it is equals to I3. And what is our I3? I3 is, we evaluated I3 as minus 7.5 milliampere, so it is minus 7.5 milliampere, right? So it means that now we have found the IN, our IN, it is minus 7.5 milliamperes. Now we can draw the Norton equivalent circuit. So Norton equivalent circuit, general circuit is like this: IN, RN, and this is our load resistance AB, and in our circuit like it is R out, right? So we will put it as R out. RN, it is 2 by 3 kilo ohm, right? And IN it is this minus 7.5 milliampere, right? Now since it is minus over here, so to remove this minus we can change the direction of this, right? Direction of this current source, so we can change the direction to downward and we will make it as plus. So this is our Norton's equivalent circuit, right? So this is the first part of the question, that we need to determine the Norton equivalent connected to the resistor R out. Now the second part is it is asking to select a value of R out such that a maximum power will be delivered to it, right? So once we get a Norton equivalent circuit, now from the maximum power transfer theorem we know that maximum power will be transferred to the load resistor only when load resistor is equal to the internal resistance. So over here load resistance is R out. So this will get a maximum power only when this load resistor or R out it is equals to internal resistance which is Rn. So Rn should be equal to 2 by 3 kilo ohm to get the maximum power delivered to it, right? So this is the answer to the second question. And over here note that the purpose, like one of the purpose of determining the Thevenin equivalent circuit or Norton equivalent circuit is to determine this type of thing, that over here to determine the maximum power transfer to the load, just we need, like if we get a Thevenin equivalent circuit or Norton equivalent circuit, from the internal resistance, from Thevenin resistance or Norton resistance, straight away we can determine what should be the value of the load resistor. So with this I end this video. If you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues.